Example 1 here on parametric integrals is taking a look at using the chain rule. So a parametric equation is x equals 3t plus 4 and y equals t squared. So we want to find the integral of y dx in terms of t. So let's just note the formula that we need for this. So this is the integral of y dx, and this is equal to the integral of y dx by dt, so dx by dt dt. So x is equal to 3t plus 4, so x is 3t plus 4. So if we differentiate x with respect to t, so that gives us dx by dt, we simply get 3 here. Okay, derivative of 3t with respect to t is 3, and the derivative of 4 here with respect to t is simply 0 because 4 is a constant. So dx by dt is equal to 3, and if we take a look now at y being equal to t squared, so y is t squared, in that case the integral of y here, dx, is equal to the integral of 3t squared dt. So therefore, the integral of y dx is equal to t cubed. So if we integrate 3t squared here with respect to t, that would simply give us t cubed. Don't forget our constant of integration there. So t cubed plus c. So that gives us the solution to example 1 there on parametric integrals. Example 2 here on parametric integrals is taking a look at definite integrals. So in this example here, we're given our parametric curve, which is defined by the following equations, for t being greater than minus 3, and we're asked to find the following integral. Now the first thing we need to do here is start by converting the limits. So in this case, if we convert our limits, well, let's take a look at x here. So x is equal to t squared plus 4t plus 4. So our first limit is when x equals 0. So in that case, I just set this quadratic here equal to 0. If x is 0, then this quadratic is equal to 0. So in that case then, we'd write here that t squared plus 4t plus 4 is equal to 0. And in that case then, I'm just going to solve this quadratic here for t. Well, this solves quite nicely. We can write this as t plus 2 all squared, which is equal to 0. And in that case then, what we do here is we can solve for t, which we just obtain minus 2 there. Okay, so that's our first value of t. For the second limit then, that's when x equals 4 by looking at the upper limit here. And again, just like we did here, all we do now is set this quadratic equal to 4. So that's going to be t squared plus 4t plus 4 is equal to 4. And again here, by subtracting this 4 from both sides of this equation, we will set this equal to 0, just like we did here. Or this was already defined for us being equal to 0. So if we do the same here then, by subtracting 4, I get t squared plus 4t equals 0. Okay, 4 minus 4, that would just become 0. And in this case then, I can factor a t out here, so I get t lots of t plus 4, and this is equal to 0. So you might notice a little bit of a problem here, in that this gives us two values of t. Here I get t equals 0, or I also get t equals minus 4. Okay. Now clearly there's an issue here, because that would give us three values of t. We'd have t equals minus 2, t equals 0, or t equals minus 4. But we just need to take a look at the example again, where we define that t is greater than minus 3. So that means t equals minus 4 is not in the range, so we omit this solution here. We don't want that one. Okay. So in that case, we conclude that t equals 0. So now let's start by rewriting our integral here. So our integral from 0 to 4 of y dx can be expressed then as the integral from minus 2, that's our lower limit, to 0 of y dx by dt dt there. Okay, so remember x is equal to t squared plus 4t plus 4, so we now need to find dx by dt by differentiating x with respect to t. So therefore, dx by dt, like we said, we need to just differentiate x with respect to t. What that would give us here is 2t plus 4. Okay, so that's 2t plus 4. And y, we already know that, that's t cubed plus 3t. So y is equal to t cubed plus 3t. Okay. So in that case then, we can replace this y and this dx by dt with what we've just found here. So this is equal to the integral from minus 2 to 0 of y, so that's t cubed plus 3t, so t cubed plus 3t times dx by dt, so that's 2t plus 4, 2t plus 4, and this is with respect to t, so dt. Okay. Now this is going to get quite lengthy, so just take note of what we've got so far on the screen here, particularly this integral so far. What we'll do now is clear the screen and conclude this integral. So let's conclude this then. So what we need to do here now is expand the brackets. So let's just rewrite the integral out just so we can see that. So minus 2 to 0 of t cubed plus 3t times 2t plus 4. Okay, this is with respect to t. So here, like we just said, we're going to expand these brackets using FOIL or an appropriate method. Okay, and if we do that here, again, it's going to be just from minus 2 to 0. That won't change. I'm going to get 2t to the 4. I get 2t to the 4 plus 4t cubed plus 6t squared plus 12t. Okay, and that's when we've collected like terms there. So now what we need to do is actually perform the integration. So we need to just simply add 1 to the power and divide by the new power. There's nothing particularly out of the order that we do here. Just add 1 to the power, divide by the new power. So in that case then, what I get here is 2t to the 5 over 5, or 2/5 of t to the 5. Okay, like that. Okay, we can express it in either way. 4t to the power 3 here, well, we'd add 1 to the power and divide by the new power, which would simply give us plus t to the 4. Okay, moving on to 6t squared now. If we integrate this here with respect to t, that would simply give us 2t cubed. Okay, and then finally for 12t here, if we add 1 to the power and divide by the new power, that would just simply give us plus 6t squared there. Okay, and don't forget our limits here of minus 2 and 0. And all we need to do now is simply substitute our limits in. Okay, so remember, we're going to substitute the 0 in first, our upper limit, and then we will substitute the lower limit in. Okay, so we should just about have enough room here to substitute our limits in. So remember, what we're going to do now is substitute the upper limit in first. That's going to be 2 over 5 times 0 to the power of 5. So let's just write it out in full here. So we're going to get 2 over 5 times 0 to the power of 5. Plus t to the 4, so that's going to be 0 to the power of 4. Okay. We don't need to write that in brackets, but I'll just keep them there for now. Plus, so this is 2 lots of 0 cubed. That's going to be plus 2 times 0 cubed plus 6 lots. So that's plus 6 lots of 0 squared. Okay. Now for the lower limit here, remember we need to minus each term here. So it's going to be minus 2/5 of minus 2 to the power of 5. Okay, so times minus 2 to the power of 5. Okay, plus, but remember, we're subtracting each of these ones off. It's going to be a minus. It's going to be minus 2, so minus 2 power of 4. So you've got to be very, very careful here with your minuses. Minus 2 to the power of 4. Now it's going to be minus 2 lots of minus 2 cubed. So minus 2 cubed. And then finally minus 6 lots. So minus 6 lots of minus 2 squared. Okay. So here now, if we evaluate each one as we go, or as we evaluate this on our calculator, what you'd get here is 64 over 5. So you get 64 over 5 minus 16 plus 16 minus 24. And clearly here the minus 16 will cancel with plus 16. That'll evaluate to be 0. So they cancel. So what I get left with then is 64 over 5 minus 24. And if you evaluate this now on your calculator, what you will find here is you get minus 56 over 5 there. Okay,